Equation forms are like shoes. This shoe provides little traction and is easy to put on, and those are the two main things about it. This shoe provides a lot of traction and is kind of hard to put on, so they present us with different things. But at the end of the day, they're still shoes, and at the end of the day, all equations still show the same line or graph that we're looking at. So that's a good way to think about it. All forms of equations describe the same thing. They're just different forms of the same thing. So yesterday we were writing equations in a specific form, and that form is called the slope-intercept form and looks something like this. So the slope-intercept form generically looks like this and is read y equals mx plus b. Now there's a couple different things and a couple special things about this form that you should know. The first thing is that you can get the slope just by looking at the equation, and your slope is always going to be the term that's attached to the x. And think about it in this, form. Remember, see how slope is still represented by m? That's going to remain consistent. The other thing that you should be able to pull out just by looking at this form is the y-intercept. And the y-intercept is represented by this b here. It's not the y, it's the b. Now, with the y-intercept, there's a couple different things that you should know about it. The first thing is that graphically, the y-intercept is where the graph of that line touches the y-axis, or that vertical or up and down axis. It's whatever y value that the graph of that line touches at. The next thing you should know is that sometimes the y-intercept is 0, and you don't see it, so you'll get something that looks, just like that. It's just that front part. Doesn't mean that there's no y-intercept. It just means that the y-intercept is 0. It went through the origin. And that's important because while you can write that 0, and you're not technically wrong, if there isn't a number tacked on at the end, that doesn't mean there's no y-intercept. It just means that it's understood to be 0. And that's really important because you don't want to look at a problem and see there's no y-intercept and just say, oh, I can't do it, there's no y-intercept. No, the y-intercept is 0. Remember, we can add or subtract 0 from anything and not change what it is. That's 0's thing. So now that we have some information on slope-intercept form and the y-intercept and the slope, let's take a look at some problems where we're pulling information directly from the equation and also writing equations given word problems. I'm sure you're thrilled to be doing that again. So the main thing that we want to be able to do is to identify the slope and y-intercept when given just an equation in slope-intercept form. So let's do that a couple of times. We have y equals negative 5x plus 3. So I'm just going to write my slope variable and my y-intercept variable, and then we can sort this out. Now, our slope is always going to be next to the x variable. It's also our rate of change, and would be in the rate of change position. But slope here is negative 5 because it's next to that x. So we just write negative 5 here. Slope is not an ordered pair. It can be a fraction, it can be a decimal if you really want, but it's not an ordered pair. So keep that in mind. And then our y-intercept is just the number that we have tagged on here, whether it's added or subtracted. Now we have a plus 3 here, so our y-intercept would be 3. Now, take a look at this second one here. Pause the video, write it out. It should only take you about 30 seconds, if that, and we'll meet back here then. So here we have y equals 7x minus 4. I'm going to write my slope variable and my y-intercept variable. And it's the same process as the one that we just did right here. 7 is next to the x, so that would be our slope. So our slope is 7. Our y-intercept would be -4. Now, keep in mind, we didn't write +3 here. You could. It's not incorrect. It's just not kosher, if you will. It's not what you do. But because we have a -4 here, we're going to write it as -4 because that's what it is. So we took a slope from the number next to the x, and our y-intercept is just the number we have tagged on at the end. So the next problem I want to look at says, suppose the water level of a river is 34 feet and that it is receding at a rate of 0.5 feet per day. Write an equation for the water level L after D days. First thing I'm going to do is I'm going to define my variables. Now, granted, they did it in the problem, but let's put it on the side anyway. So L is going to be our water level and D is going to be our number of days. So we defined our variables. Now it's important to ask the questions, what are we looking for? What are we trying to find? Well, it's asking us to find the water level after so many days. So our final product here, our final answer here is going to be the water level. So I would say, maybe write L down. And L is going to equal everything else. Next question we should ask ourselves is, what changes? What's changing here? What can be different numbers? And that would be the number of days. That would be the number of days. We're not going to write that down quite yet, but that would be the number of days. Next thing you want to ask yourself is, what is our rate of change? Well, the rate of change would be this receding 0.5 feet per day. If it's receding, that means it's minus. So our rate of change is going to be a negative number. We're losing 0.5 feet, or negative point. We're losing 0.5 feet per day. So it would be minus 0.5 feet times the number of days, because we're losing that per day. We're losing this negative 0.5 per day. So it would be multiplied by the number of days. Lastly, we want to look at what was our initial level. What did we start with? Well, the river started at 34 feet. So I'm going to tack on, since it's a positive 34, plus 34. Now, this is one way of writing it. There is another way, in a way that makes more sense. So the level that we're looking at, given a number of days, is going to be equal to our initial level, which is 34, minus 0.5 times d. Because we're taking away, a number of feet per the number of days. Like, we're taking away level from the 34. The level's not going to go up. It's going to go back down. So it would be 34 minus 0.5 d. Now, let's recap and talk about what we really did here. The equation that we have here shows our water level, which is what we're looking for, equals our rate of change, which is minus 0.5, because we're losing half a foot of water each day. So we have negative 0.5 times d, or the number of days. And our initial level was 34. And you can do the same thing here. Our water level equals the initial water level minus half a foot times the number of days, or minus 0.5 times D. That's how you want to approach these problems. It doesn't matter what variables they give you, as long as you define them, tell me what they are, and just be consistent and know what you're using when. That's why you define them. So that's how you go about approaching these things. So the last problem that I want to look at today says something like this. For babysitting, Nicole charges a flat fee of $3 plus $5 per hour. Write an equation for the cost C after H hours of babysitting. So what I want you to do is take a second, pause this video, work this out, and then come back and we can work through it together and you can check your work. So the last problem I want to look at says this. For babysitting, Nicole charges a flat fee of $3 plus $5 per hour. Write an equation for the cost C after H hours of babysitting. First thing I want to do is I want to define my variables. I know it's here, but I want to see it my own way. So I have cost, or I have C, and I have H. As I alluded to about 5 seconds ago, C represents our cost. H, it says, represents our hours of babysitting, so I'm just going to put hours. Now that I have my variables defined, I can start writing my equation. First thing I want to ask myself is, what are we looking for? What are we trying to find? Well, here we're trying to find the cost, the total cost. So my whole equation is going to be equal to C. So we'll have C equals. Next thing I want to find is my rate of change, my something per something. Well, here we have $5 per hour. So I'm going to write that down. $5, and then to write down per hour, we would just multiply that $5 times the number of hours, or our variable 4 hours in this case. So we have 5H. So far, we have C equals 5H. Last thing I want to ask myself is, are there any initial fees? What's my starting place? What does that look like? Well, it says Nicole charges a flat fee of $3. So I'm going to tack on a 3 at the end because there's an initial fee. And no matter how many hours she babysits, there's always going to be an initial $3 that you have to pay. So let's run it back and recap. We saw that we were looking for the cost. We want to find the total cost. So we said C equals our rate of change, which we have $5 per hour. So we have 5 times the number of hours plus the initial fee of $3. And that's how you would do this type of problem. So before we go for today, let's talk about what we actually did and everything that we accomplished. Today we talked about the slope-intercept form of an equation and what that means to us. By having an equation in slope-intercept form, or y equals mx plus b form, we can pull out 2 different things just by looking at it. The first thing is the slope. It's always going to be that term that's attached to the x variable. We can also pull out the y-intercept. Again, this is just by looking at it, and the y-intercept is always going to be that term that doesn't have a variable, but is added or subtracted to the slope term. Now, the y-intercept has a couple different properties. The first one of these is that when you graph your line, it's where the line touches the y-axis, where it touches that up and down vertical axis. The other thing to keep in mind is that the slope-intercept can be 0, and that doesn't mean it exists, it just means you don't have to write it. Because when we add or subtract 0, it doesn't change anything, so we don't need to write it. So keep in mind when you go to do your problems that if it doesn't have a slope-intercept or a y-intercept attached to it, that doesn't mean it's not there. It's just understood to be 0. The other thing that we did was we looked at how to write equations in slope-intercept form given some information, and we did that by doing the same thing we did yesterday. We defined our variables, we found our rate of change, we found our constant or our starting value, and then we wrote the equation given the information that we already had. Well, that's kind of it for today. Tune in next time for when we do something. I don't really know what it is because this is the last video on the list that I was given, but we'll do something. Yeah. But for now, you've been the students, I've been the teacher. Thanks so much for watching. I'll see you guys next time.